right, this is Algebra 2. This is from Lesson 3, and this is just a few problems from Section E. And if you're having problems with anything on Lesson 3, you might try these, and if you get stuck, come over here, see how to do them, and then try them again on your own. And then if you miss them, come back, see where you went wrong. But it wants you to divide these using scientific notation. So yes, you could crunch it in your calculator, but in order to get credit, you're going to have to follow the directions. So let's put this in scientific notation. In order to do that, you're always going to put your decimal one place after the very first non-zero number. So I really want my decimal to go right there. So I'm going to write this as 1.6, because we really don't even care about all these zeros over here, times 10, and then just count. How many places did you move it? It was here, so I moved it 3, 4, 5. So it should be 1.6 times 10 to the 5th divided by, I'm going to show it like this. You don't have to do that. I just prefer it that way for me. It's all the same difference. Okay, write this one in scientific notation. Very tiny number. I need my decimal right there between the 5 and the 3. So notice I'm moving this 1, 2, 3, 4, 5, 6, 7 places. So I'm going to write this as 5.3 times 10 to the negative 7th. This represents a very tiny number, because actually you would be dividing by, when you have a negative 7, an exponent, remember that's like you would have to put it in the denominator, so you'd be dividing by a huge number. That's what makes that so tiny. Anyway, use your calculator, and in your calculator, is that nice and clear, hopefully? You're going to take 1.6 divided by 5.3. So let me grab my calculator real quick. Let's see what we get. You can even look over here if you want. I'm going to do, gosh, I can't even remember what I'm dividing in. 1.6 divided by 5.3. And look at that ugly answer. Obviously, we're not going to write all this down. So let's just write down like the first 3 digits. It says 0.301886, blah, blah, blah. How about if we do 0.302? Because, see, since this 8 right here, since that's 5 or more, we're going to round up that number to a 2. So I'm going to write this as 0.302. Okay, 0.302. Now this is just an approximation since I just rounded it off. Times 10, and look right here. You remember you divide. What do you do with these exponents when you divide? That's right, you subtract. So be real careful. What is 5 minus a negative 7? And think about it. You're doing this in your head. 5 minus a negative 7. Remember that is the same thing as adding. So you should get 12. So we've got this. 0.302 times 10 to the 12th. Now, that's good. That's a great answer, except I have to sit down. I'm getting tired. That is not in the correct place. I actually want my decimal. I'm going to get a different colored pen. I want my decimal right here. Remember, it's supposed to go after the first non-zero number. So I actually want it to look like 3.02. So I want you to think about this. Who wants to tag on, all these places? But what that decimal, since this is a positive 12, it's telling me I would move this decimal 12 places this way. Well, if I move my decimal here, do you see that now I'm going to only have to move it 11 places? Okay, I'm not going to have to move it nearly as far. So that would be that one right there. If you can't see that, my suggestion would be to go ahead, move this 12 places. You've moved it 3, so now you're going to have to tag on like 9 more zeros. And then go ahead and put it in proper scientific notation, and you'll be able to see that you then had to move it 11. So do it the long way for a few times if you don't see it right off. Okay, let's go down here and let's do number 10. And I went ahead and I wrote it out. If I hold this way up here, you can see the whole problem at one time. But we're just going to take a little piece at a time, and we're going to try to get rid of negative exponents and simplify, so hopefully this just doesn't look quite so gross. So let's look right here at this one. Okay, what I notice here is I have x's both here in the numerator and the denominator. Same base. If you don't see an exponent, it has an exponent of 1. And we're dividing. So my question is, what can you do with these exponents since you're dividing? That's right, you subtract. And, so you think about it, 2 minus 1 is 1, so you're going to get x to the 1, if you want to say that, x to the first. Typically, I don't write that one, but I'm going to show it. Another way to think about this is, hey, where are there more x's? On the top. How many more? 1. So it looks just like that. Now look at your y's. Again, this is like y to the first. Where are there more y's? On the bottom. How many more? 1. So I'm going to have 1y on the bottom. Now, I just think that's a pretty easy way to think about it. If you would want to, you could also, again, if you subtract this, you would get 1 minus 2. Well, that's a negative 1. So you could write this like this. Let me write it right below here. I am not a fan of that. Okay, that's maybe the way Matthew C. shows it. I don't like to deal with negative exponents. So what do you do with the negative exponent? If it's in the top, how do you get rid of it? You put it in the bottom. So you're going to end up with this right here anyway. So, okay, let's move on to the next term. The very first thing I would do personally, I would be getting rid of these negative exponents. And how do you get rid of them? Well, if they're in the bottom, you're going to put them in the top. So I'm going to take this guy and I'm going to put him in the top. So he's going to look like y to the positive 1 now. I'm going to take this guy. He's got a negative exponent. And he's like, I don't want to be negative. I want to be positive. He's in the bottom. Put him in the top. So we would have this. So I'm going to rewrite this because that looks kind of gross. I would have 7x squared y. That's what I originally had. And now I've got another y and another x. And I have like nothing in the denominator. So if you wanted, you could show it like that. Okay, so what do you have? I've got a 7. So let me see, minus 7. Look how many x's here. You have x squared times x. If you're multiplying, what do you do with your exponents? You add them. So you would have x to the third, y, notice you have a y to the first times y to the first. Add those exponents, you're going to get y to the second. So you get that right there. Okay, last little term. This is my favorite because what's x to the 0? Boop, it's 1. It's gone. Don't even have to worry about him. I do see this negative exponent. He does not make me happy because he's negative, so I'm going to move him down here. So if he's negative, Allison's wiggling the table there. If it's negative, I'm going to move him down to the bottom, and it's going to be to the positive 1. So what does that give me as my final answer right here? Let me come right down here. We've been writing this. We're going to add. That would be 5. What do we have for our x's? We just have a boring x on the top. Looks like we're going to have a y to the 4th on the bottom. So x, y to the 4th. Holy cow. Okay, so there you go. And again, I'm not going to totally rewrite this one, but personally, I would be writing this over y, like that. That's just my preferred way to write it. There are no like terms there, so there's nothing that you can even add together. So I think I'm going to go ahead, and let's go ahead and do an honors problem as well. Let me see here. I've got it maybe written out. Actually, what I've got here written out is number 12. So let's do number 12. How about lovely number 12? Because it looks good. Look at all those A's and B's all over the place. Good grief. This is still from section E.